Now you can hear me. So, just like we learned the derivative of e to the x is e to the x, we're going to learn that the derivative of, so we got derivative of natural log of x is equal to 1 over x. You might wonder why the proof is fairly involved. Not going to be real good for us to go over it. It's going to take a lot of time, like it would take us the hour. Okay. So we'll just skip that. Can you memorize that? So I'll show you the other one. You don't have to memorize this. Okay? Don't have to memorize this. We're not going to do it at all. Okay? But I'll show you because it's kind of related to what we did before. So what's the base of a natural logarithm? It's a letter of the alphabet. E. Very good. So suppose you had something that had a different base, like a base of 10 or a base of 2. It would say log base b of x. So the derivative of that would be 1 over x times the natural log of b. Does that kind of ring a bell to a little bit of what we did right before break? Remember how when we took the derivative of something that didn't have a base of e, we had to attach a natural log onto it? Remember that? So not going to have to use that one, but we are going to use this one. So we're going to use some of the properties we did yesterday to make some of these derivatives easier. So we're going to look at 2 ways to do problem A. So I'm going to do way 1 right here and then way 2 right over here. Okay, here we go. I have the natural log of this thing. That's a key that I'm going to use a chain rule. Again, as you say it, natural log of another function. So we set up the chain rule. On the outside of the natural log of u. What goes on the inside? 1 over x squared. Let's rewrite it so it's an exponent form, power form. X to the negative 2. Thank you, Dr. Bijak. What is the derivative of the natural log of u? 1 over u. Good. 1 over u. No, 1 over u. See, it's so fun. Like calculus has all these neat parts. Yeah. All right. What's the derivative of x to the negative 2? Look at how smart you are. Now, we've got to be careful. Okay, we've got to be careful. We plug this into here, right? Yeah. So that would be 1 over x to the negative 2 times negative 2x to the negative 3. Ugh. That's kind of gross, isn't it? So let's deal with those negative exponents. How should I write 1 over x to the negative 2? X squared, yep. So x squared over 1. Run fast. Don't slip on the grass.
You do make it look cool.
That didn't rhyme. And then how do we rewrite negative 2 x to the negative 3rd? It would be? Okay. So if I take x squared over 1 times negative 2 over x to the 3rd, what is going to be the final result? Great. So some of you will do the problem like that. I'm going to encourage you to take the derivative in a different fashion because there's an easier way of doing it. Do you like easier? Except it's going to require you to remember the stuff that we reviewed. Okay? And so here is how it goes. If you can't do this, then you have to do the chain rule like we just did. Watch how I work through this. The natural log of 1 over x squared, I'm going to write as the natural log of x to the negative 2. Everybody okay with that? What did we learn you could do yesterday? We learned when you have the logarithm of something to a power, you can just take that power and dump it out front, right? So this becomes negative 2 natural log of x. Have I taken the derivative yet? No, I've just rewritten it, right? So watch how easy this is. What's the derivative of natural log of x? 1 over x times negative 2, negative 2 over x. So I was thinking about this last night, actually. I was watching Timberwolves game, got to halftime, and usually when I'm thinking about things, I think about you guys because you're the best. I love you. You're so wonderful. And you bought me some Mountain Dew, which makes me really happy. But here's something that you start to do that you can't just do, okay? Let's make sure we understand this. Natural log of x cubed, sine to the fourth of 3x, and 6 minus 4x to the 10th, okay? So, true or false? I could bring this 3 out front. Yeah, 3 natural log of x. But people like to move that even further. They're like, oh, just take the 4 out there. We got 4 sine of 3x. Can you do that? No. This is my favorite one. Like, well, just bring the 10 out. So we got 10 times 6 minus 4x. So it's just like 60 minus 40x. Yeah, done. Derivative negative 40. Boom! Totally illegal, right? It works with logarithms. Nothing else. We good? Okay, tried to have some dramatic effect here. Nobody says I should go for theater. I thought it would be a good fit. All right, next one. You got 2 options. I'm not going to carry through both options. I'm just going to set up the first for you. You could say the natural log of u. So, I have the natural log of u. What would u be in this situation? X sine of x. So, I'm sorry. In this situation, I would have to put those parentheses on the test. Sorry. Those should be there. Yep. Do you see it now? Yeah. Otherwise, you could read it as the natural log of x times the sine of x and say that's the product rule. My bad. So, we're going to say natural log of u and x sine of x. Now, if you take this derivative, what would you have to use? Not chain, but product, because you got x times. Right? I don't want to do that. Everybody else agree? I don't want to do it. Let's do something else. Let's rewrite this. Instead of natural log of x times the sine of x, let's write it as 2 logarithms. Natural log of x plus natural log of sine of x. You see that? Just a nice little trick. So what's the derivative of natural log of x? It's 1 over x. Okay, good idea. You say 1 over sine of x. This is, okay, it's natural log of something. What rule do you think we have to use? It's not natural log times, it's natural log of chain rule. So I have the natural, there's no way of avoiding the chain rule here. It's just we can make it simpler. So I got the natural log of u. What's on the inside? Sine of x. What's the derivative of natural log of u? 1 over u. 1 over u. 1 over u. What's the derivative of sine? So it's going to be 1 over sine times cosine, which would be, okay, good job, cosine of x over sine of x, which as you said is, say it again, cotangent. Good, so the derivative is 1 over x plus cotangent of x. Where?
The cosine over sine?
This part?
Yeah.
So here's what I do. We got cosine over 1, agreed?
Yeah.
And the sine goes in for the u value. So when I multiply these two things together, cosine's on top, sine's on bottom.
Okay.
Is that better?
Yeah.
And then our friend said that cosine over sine is cotangent. Good with that? Yeah. So I think that that's an easier way of doing it. So using your laws of logarithms is a good thing. All right. Letter C. What rule do you think we have to use here? Quotient rule is correct. So let's use the quotient rule. F prime of x is equal to, I take the derivative of the top, which is 1 over x times e to the x.
I need to put the link.
Yeah, so remember the quotient rule is f prime g minus g prime f all over g squared. So that's what we're doing. If I take the derivative of the top, the derivative of natural log is 1 over x times the bottom. We good?
Yeah.
Minus, what's the derivative of the bottom? Isn't it just so fun? It's like your favorite derivative ever, isn't it? Times what? All over. So it'd be e to the 2x if you square it. Do you think this is simplified? No, it's not. Not simplified at all, is it? Nope. We got two problems. Number one, we could factor out an e to the x, couldn't we? And then also you got a complex fraction here, right? You got like a fraction of fraction. So we got just a little bit of work to do. Let's factor out that e to the x. You okay with that? So e to the x times 1 over x minus natural log of x divided by e to the 2x. Yeah, so e to the x over e to the 2x, one of those will cancel, leaving just 1 e to the x in the bottom. We agreed? Okay, so I'll write it as 1 over x minus, I'm going to write natural log of x over 1 over e to the x. So we took care of the e to the x. I now need to deal with the fact that we have a complex fraction. So if I have a complex fraction, what do I have to do? Common denominators. So what's common denominator? X will multiply top and bottom by of this natural log of x expression. Notice we get 1 minus x natural log of x over what? X over e to the x over 1. So I now have one fraction over one fraction. What do you do then? Multiply by the reciprocal. So we get 1 minus x natural log of x over x e to the x. It's okay. It's kind of a challenge, though. If you don't like letters, it kind of rules out Spanish, English, math, kind of most everything just kind of disappears. So even texting disappears. All right, so, oh, was that a wait? Because the next one's my favorite. We good? Can we agree that letter D looks super difficult?
Well, guess what?
So, promise, okay, again, you can call me ugly, call me stupid, call me bad teacher, call me whatever you want. You can't say I don't tell you what you're going to need to know. You have to know this problem for the test.
Okay.
Oh, wow. I thought I was going to go like, thank you, Mr. Getz, like it's Merry Christmas time. But I got, oh no, we're going to have a test on this. Okay. So, here's what I'm going to do. So, this should really have an f of x here in order to be appropriate notation. But what I'm going to do is I'm going to use our laws of logarithms to separate this a little bit. We're going to write this f of x, so I'm not taking a derivative, but I'm going to write the natural log of x plus 2 to the 4th, and I'm going to write plus the natural log of x minus 3 to the 10th. So I saw that I had the natural log of two things that were multiplying each other, so I separated it to two addition pieces. Are you okay with that? It's a really good choice, and trust me, it's a lot better result. What is the next thing I could do? Yes, chain rule, but before I do that, yeah, drop your exponents out here, and then it's going to be even easier. So again, I'm writing f of x because I have not taken the derivative yet, and I have 4 natural log of x plus 2, and then I have 10 natural log of x minus 3. Well, that looks really nice, doesn't it? And now we're going to go to Alex's idea, which is, hey, we'll just set up the chain rule. We'll do it once here. We'll do it once here. The outside is 4 natural log of u. What's the inside? What's the derivative of 4 natural log of u? Yep, 4 over u.
Oh, forgot. I just think it's like
41. It's 41. I like it. Thank you, Morgan. Bring joy to my life. What's the derivative of x plus 2? 1. Isn't that great? Like, well, it ends up being 1. So we get the derivative is, so we take this 1 and multiply it by that, right? So it's just 4 over x plus 2. So what's the outside here? 10 natural log of u. What's the inside? Derivative of x minus 3. Derivative of 10 natural log of u. Multiply the two together. Now, you could combine those, but that doesn't necessarily help you at all or reduce anything. I say we just leave it like that. Dr. Jeffrey, in your expert analysis, do you think that this is one we could do for the test? Awesome. A plus for everybody. Yeah. So, to be clear, because this is an excellent, excellent point, you saw there was multiplication right away, right? If you set it up like this, natural log of u, and then on the inside it was x plus 4, or x plus 2, excuse me, to the 4th, times x minus 3 to the 10th, then when you found this derivative here, you would have to use the product and the chain once, and the chain a second time. So you would have to do all that. And that would be a lot of work, right? I think that rewriting it makes it a nicer option. So what did we do? We just had to use the chain rule twice, and it was actually pretty straightforward. Whereas in this situation, it would be different. So if you set it up like that, which I have had a few students before that refuse my option, they do choose this, go ahead. It gets really messy. Got it? All right, flip it over. So this was my good friend Michelle. Everybody say hi, Michelle. Michelle brought this one up the other day about, like the square root sign, like where does it go for sure, and does that matter? And you can see in this case it really does, because it's a square root of the entire piece, right? So I want to get this out of the way right away. This is not equal to the natural log of 2x minus 1 to the 1/2 power. It's not the same thing. Here's what it is equal to. F of x is equal to the natural log of 2x minus 1, that entire quantity, meaning including the natural log, all to the 1/2 power. So there's a distinct difference. Can I just drop this 1/2 in front? No. If it was this way, then I could drop the 1/2 in front. So that's what we're trying to iron out. So this is a setup of the chain rule. Does anybody see what the outside will be? U to the 1/2. Good. Very common piece. You notice we come up with u to the 1/2 a lot. Anybody derivative of u to the 1/2? Remember that guy? Good. Man, you guys are smart. All right, and then let's do the inside would be. Okay, how are we going to find the derivative of natural log of 2x minus 1? Yeah, we do have to do that chain rule. No big deal because we're really smart. What's going to be on the outside? Natural log of u. Inside? Derivative of natural log of u. 1 over u. Derivative of 2x minus 1. So we get 2 over 2x minus 1. So when I multiply, I'll pause. So when I multiply these two expressions together, what do you see is going to reduce right away? Everybody see the 2's are going to cancel right away? This 2 with that 2. And then this expression, as we know, it goes down there. So what am I going to have in the numerator? 1. And the denominator, we've got the square root of the natural log of 2x minus 1 times the quantity 2x minus 1. So it's not real pretty, but it works. We got 2 left. Natural log of that thing. Any idea? Excellent. So column C's, we're going to set up natural log of u, and on the other side, this entire thing. But that's way too much work. I don't want to do it.
Would you expand it?
Say it. You guys got good ideas. Subtraction. I mean, isn't that nicer?
Yes.
And then what's the next thing we can do? Dump the 5 in front, right? So we got the natural log of x minus 5 natural log of x squared minus 2x plus 4. True or false? We've taken the derivative. False. We've just rewritten it, right? So now let's take the derivative. Derivative of natural log of x. And then what will I use to find that derivative? The chain rule. Let's set that guy up. What's on the outside? 5 natural log of u. Good. What's on the inside? Good job. What's the derivative of 5 natural log of u? 5 over u. Good. And what's the derivative of x squared minus 2x plus 4? I'm going to write it over 1 just so we can see it. I multiply these 2 together. So what are you going to get in the top? Yep, 10x minus 10. Good. And in the bottom, x squared minus 2x plus 4. Good. Definitely a lot better than setting up the chain rule right away, because then we would have like the quotient rule, right? You can see how like involved that would get, right? So logarithms are super, super cool that way. Last one. Ready? Here we go. Looks really bad. Maybe it's not too bad. What rule? Got to use the quotient rule. So, Lindsay, to bring back to Lindsay's point, if it was the natural log of, say, x minus 3 over x squared plus 2x minus 1, well, in that situation, we could use subtraction because it's natural log of this thing, see? But here it's just a fraction that involves 2 natural logs. So got to rid our mind of that, okay? Good. All right, so we've got that. So it says take the derivative of the top. What's the derivative of the top? 5 over x, good, times 4 minus 2 natural log of x. The derivative of 5 natural log of x. What's the derivative of natural log of x? Times 5 would be 5 over x. And the derivative of 3, we got is 0. Minus, what's the derivative of the bottom?
2 over x.
Negative 2 over x. So plus 2 over x. Times then 5 natural log of x plus 3. All over. It looks kind of bad, doesn't it? Yeah, exactly. You're going to see some things cancel out. Let's watch if some things cancel out. I'm gonna leave the 1 over x out here. I'm just going to distribute the 5. Okay? And when I do that, 5 times 4, so I got 1 over x times, that's going to be 20 minus 10 natural log of x plus, I'll leave it as 1 over x times 10 natural log of x plus 6. All over, 4 minus 2 natural log of x squared. So do you see the positive and negative 10 natural log of x? Like you can see that those are going to cancel, right? So what term do these two things share in common? What do they both have in common? They have a, right. So can we just take that guy out and then watch things cancel? So I got 1 over x times, I'm left with 20 minus 10 natural log of x plus 10 natural log of x plus 6 all over 4 minus 2 natural log of x squared. So what is this inside thing here? What does this simplify to? 26, right? So doesn't this thing just come out to be 26 over x divided by 4 minus 2 natural log of x squared? Can we leave our answer as a complex fraction? And I know that that sounds like, oh my, we've got so much to do. We really don't. We just need to take and multiply by the reciprocal, right? And so we just get 26 over x times 4 minus 2 natural log of x squared. That's it. Good job. You learned something really important today. What's the derivative of natural log of x? 1 over x. What's the derivative of e to the x? Look at how smart you are. You are ready to move on to your first assignment. You got a good 13 minutes. Be good to knock out 4 problems or so. I'll find the answer key and post it.